Alright, in this video we're going to look at putting together a small coding project which looks at taking out some data from a database using SQL queries, as well as some of the things we can actually do with SQL queries within our coded prototypes. So the first step is to download the database file. You can see I've already done that and it is sitting in my project folder. Just to quickly overview the data set, there is just one table. Obviously, if you get the SQLite sequence table, there's one table called orders, and in there you'll see there's three fields: order ID, customer name, and order cost. So we're going to basically create a little prototype which will allow us to search for specific customers, as well as calculate their total order cost. So I'll close that up, we don't need that anymore. So the first thing we need to do, as with any project, is to create our Kivy files. So for our app, so we're going to import Kivy. Actually, I forgot the very first thing we should always do, which is to save it straight away in the folder. So main.py, save as, or save. I'll just call it screens.kv, and I will add in the builder file. That's probably the easiest way, rather than worrying too much about the naming. So put that little comment in that Kivy likes to stop throwing an error, and we can get back to it. So from the app library in Kivy, we want to import the app object. From the language library, we'll import the builder, and then from the UIX library and the screen manager section, we'll import screen manager, as well as our screen object. So we'll only use a single screen in this, but we'll set it up as though we could do multiple screens. So within that, I'm going to create a object. I'm just going to call it data screen because it's going to display my data. Nothing too imaginative there. And this one I'm going to call query app, just because the purpose is to test queries and practice running them. So we'll build application. So from the builder module, we want to load the file, screens.kv, maybe without a capitalization. Build an instance of our screen manager. We'll add a widget, and that is our data screen. I'm not going to put a name on it because we're not going to be handling transitions in this. And then we'll just return the screen manager. And as always, we finish with our if dunder name equals dunder, in quotes, dunder main, then query app dot run. Alright, so we always test once we've set up the bare minimum, and it always opens up on the wrong screen when I'm doing tutorials. But you can see we've got our blank window ready to go. Alright, so the next thing we're going to do is connect our database in. And so we've previously done activities that have accessed the database. So just get my folder open, and I will find on the other screen where I've previously saved my database library. There we go, this one will do. Actually, I want to copy it, I won't click and drag it. I'll copy and paste it. So you can now see db.py. If I open that up, we covered Actually, that's the wrong file. I might try overriding this one. Get rid of that one. Copy, paste. Let's see this one. There we go. So that's the one I wanted. That was a complete one. So we connect to our database. We can create tables, but we've already done that with our preloaded database. We can create data. We're not actually going to create any data in this. We're going to use the read data. So basically to query the database and get data back from it. So now we have the correct database library in place. We can access that. So in our query app, when we initialize it, we're going to set our database to be from the database library, create a database with the data.db file. So I do need to import the database. So remember, squiggly line in this usually means that you haven't imported what you're suggesting that you're wanting to add. And then the connection is from that database. We're going to run the db connect method, which will create the connection to our database file. We can run it just to make sure we haven't made any syntax errors, but still nothing happens because we haven't got any interface. We can't really see the connection until we attempt it. Alright, so the next thing we can do is we've got our template set up, we've got our data connected. Let's add in our interface elements. So on the data screen, we're going to add a search bar at the top of our screen. And to do this, we're going to use an object we haven't used before called a box layout. So in my previous tutorials and coding projects that you've done, we've used a grid layout just because it simply organizes it into a grid. A box layout is good when you want a bit more control over the size and positioning of elements. It doesn't just sort of put them into a tabular format. With a box layout, the one attribute that you should consider is the orientation. So whether it's a vertical or a horizontal orientation. And what that means is whether the elements in the box will be organized horizontally or vertically. Alright, so we're going to use a combination of both, but my initial box layout, I'm just going to set the orientation to vertical. And what this will do is it'll perform a similar output to creating a grid layout with a single column. So basically everything will go underneath each other in a singular column. Alright, but inside that, what we're going to do is we're going to use another box layout for our search bar. And because it's a search bar, it's going to be horizontal. I guess if it was a case of you wanted to do like a search bar or menu bar on the left, you could do another vertical orientation, but I'm doing a search bar across the top, so I'm going horizontal with mine. As I said, with the box layout, it gives us more options around the sizing and positioning of the elements. So what I'm going to use is a attribute called size hint y. And what this means is it's going to set the height or the y value of the size of the box. And because it's a size hint, it's going to be relative to the size of my window. So this will create a responsive search bar. The size hint, well, I'm just going to set it to 0.1. So 0.1, if you turn that to a percentage, is 10%. So the search bar is going to represent 10% of the height of our window. So it'll be this, the top 10% will be the search bar. So then inside this horizontal box layout, I'm going to add three elements. I'm going to add a label, doesn't need an ID, because this is just going to be a text saying search customers. So basically prompting the user to search for what customer they want. Size hint X. So now what I'm doing is I'm representing or giving a clue as to the relative size of the x-axis or the horizontal. So I'm going to say 0.25. So basically what I'm saying is this label will take up a quarter of my total search bar in the horizontal axis. We then need a text input. So this is obviously where we search for our customer. So I'm going to give this an ID of search. I need to indent that. Why is that not indenting? There we go. And I'll just set multi-line to false, just so it all goes on one line. And then the third one is a button. So the text for this one is going to say search. I'm going to give this one a size hint as well. So size hint X 0.2. And we'll set up our on press. It's going to be root.search. db is the method that we're going to set for this one. Alright, so you might notice that I didn't do a size hint for text input. So basically, Kivy will pick up that, okay, this is 0.25, and because it's the first element, it's on the left. The button has a size hint of 0.2, so it'll make that. But because it's the last element within this box layout, it will move it to the right, and then the text input will take up all the space in the middle. So you don't have to define every element if you're doing something like this. You can just leave one a bit flexible, because then you can adjust your label and your button to manipulate that. Alright, so that's all we want in that box layout. But then I guess in our main box layout, I'm going to use one more box layout, and this is going to be for our output. So I'm going to set the orientation of this one to vertical, so the results will cascade underneath each other. And importantly, I'm going to use an ID of results. Alright, so giving this box layout an ID allows us to now dynamically add elements into our screen. Excuse me. So this is something we probably haven't looked at so far. We've very much sort of had things set up and in place to statically add or change value. So we might have had dynamic labels, but maybe we don't necessarily know how many orders each customer has. So we can't sort of have a set number of rows available. We do want it to be flexible for the amount of data that we have. So by setting up a dynamic layout, it'll allow us to programmatically add elements to update our interface. So once we've added all those, I'm going to save that and give it another test run to make sure we've actually got our search bar. So you can see we've got search customers at the top, we've got the search bar in the middle, and search on the side. And you'll notice as well that it's probably not quite 0.25, 0.2, but as we stretch it out, you can see it does get further and further. I guess that the button seems to have a fairly set size, but if we squeeze it smaller, you'll see it does go with that. Alright, and then I guess also if we stretch it up and down, you'll see that the search bar gets thicker as it goes up and down. Alright, so we can get rid of that now, and we can start looking at interacting with this dynamic interface. So when we want to add stuff to our interface, alright, it works the same as adding in these other elements, like particularly our screens. So our screen is an interface element that we've added into our Python file. And we want to do the same thing for, say, a label. So Kivy UIX label is the library, and from there we can import the label object. Once we've got our label, we're now ready to actually make something in our search DB method. Alright, and so I guess previously when we've done this, we've said search object property none, which obviously means we need to then go from Kivy dot properties import object, not project, property. So that now makes sense, but it doesn't know what search is, so we always have to, oh sorry, that should actually be outside of it, so we can then access it. But then we also have to do a little bit extra up here to say that the search is the search. Alright, and then what we would normally do is say print self.search.text. Alright, so if I just clear the terminal and run this, and I'll do it so you can see it, run a bit of test, and it already has an error. Did I spell it wrong somewhere? I must have spelled it wrong here. I did too. Can happen to the best of us. Let's run it again. So if we run a test, so it prints test here in the terminal. But obviously we want it to appear on our screen, but we don't have anything currently here in our results layout to display it to. So what we can do is very similar to how we add a screen to our screen manager. We can add what's called, or we can add a widget. It's not called a widget, we can add a widget. So what we can do in our search is we can say self.ids, so IDs, and we're looking for the ID called results that sits within our data screen object. Dot add widget. We can then add a label which we've imported from the Kivy library. And then just like in our Kivy language, our KV file, we can define the text. So the text equals, and then we can say self.search.text. Alright, so once we've wrote that, we should be able to do our test again. So test, and when we press search, it now appears in our results box layout. So that's how we can access our interface and then dynamically add elements to it. Now we've got our interface working, we can start focusing on well, let's actually get the data out of the database, because obviously if we type test, we don't want it to just say test, we want it to search the database for a name of test. So when we're trying to work out what we want to achieve from our queries, there is a bit of a process that we can do, and it's probably something I haven't talked about enough in class previously, so I think there'll be a video, probably maybe by the time future years watch this, the video will already be there, but going to do the coding bit first probably, and then you guys will see the video after that. But what we do is we basically start with the concept of starting at the biggest point and working our way down. So with our SQL statement, we're just going to start super simple. I'm just going to say select all with the asterisk from orders. Basically, I'm just saying give me all the data in the table so I can see all of it. Alright, then we run our query. So this is the same as what we did previously in activities 4 when we were looking at logging in the user, because we had to query the database to check the user existed. So what we do is we say from the query app data, so basically the database that we've defined in the query app, dot read data, so we're calling the read data method for the database that we've initialized. We then have to get the connection, so that's query app.con, so the connection that we created in the application level, as well as the SQL statement. So just the SQL that we just wrote, we're going to pass that in. Alright, so if we want to see what our query returns, we just change our label. So instead of the text being what we've put in the search bar, we want it to return the results based on our SQL statement. So I'm just going to use the string method and put query. And you'll see why I'm using the string method once we run the program. So give it a run, it all works. So if we want to search for all the users that start with S, or customers I should say, that start with S, and run search, it hasn't given us anything just yet. Why is that the case? What have I missed? Add widget label with that text. Have I not connected the database correctly? Oh, hang on, I know what the problem is. Oh no, that's not the problem, because we shouldn't be using the interface yet. The search yet. It shouldn't matter what we put in here. It should return all the values. This is a good opportunity to do some debugging, so we don't edit these videos. We work through the mistakes. So I'm going to try and print the string of the query to see that it does actually work. I need to kill the terminal, run it again. Alright, so we are getting all the data there, but why are we not able to print it there? Alright, so after a bit of playing around in the background, just edit that out. Basically what it's come down to is I think there was too much data to display. So if I can display the first value, that is the first value in the database, Alice Johnson, order 1. So I think it was just too much data, because there is a lot of data in the database. But now that we know it works, we can refine it, because we don't want that much information anyway. If we're being smart about it, we don't really need all the information at this point. We're just searching for the customer's name. So let's refine it by selecting just the customer's name from the orders. And I'm just going to go back to this. So hopefully we'll find that what we get as a result matches what we get on the output. So kill the terminal, go again. Alright, so hopefully we're going to get all the customers' names. So again, we're getting them here, but we're not getting them in here. Alright, what am I missing? That's alright. Maybe if we build it all out, it will magically work. Alright. So we've now got all the customer names, albeit in the terminal. We haven't quite got it in the output yet, but that's fine. Alright, but when we're looking for something like, the customers who begin with the letter S, we can use a keyword in an SQL query called like. So what we do is we say where the customer name, because we can't say it's equal to because it's not going to match up exactly because we don't know the customer's name. But what we can do is we can say if the customer's name is like, and then if we're using double quotes for our SQL statement, make sure you use single quotes just so Python doesn't get confused and split up your statement. So if we say capital S and then the percentage sign is what we call a wildcard. So basically it means that we don't care what comes after the capital S, but we need the name to start with a capital S. Alright, so let's save that. Kill the terminal. Run it again. Alright, so if we say capital S, again, it's not related to that, but you can see now we've got a reasonable amount of data. It's actually been able to put it on screen, albeit some of it's off to the side. But if you have a look in the terminal, you can now see that all the data is the names that begin with S. So there's a few for Sam Winchester, and then there's a few different S's that we've got added in there. Alright, so I guess with our output, we don't necessarily need Sam Winchester 5 times when we search for the names. We just need to know, okay, Sam Winchester is a customer, and we can then search for all of Sam's orders if we want them. So the keyword that we use there is we use distinct. So we're only selecting distinct customer names. Basically, if the customer name already has been returned, we won't see this one again. So if we kill the terminal, rerun, so constantly testing as we go. Yes. So you can now see we're down to 6 unique names, all different customers that have orders in our database. Alright, but I guess obviously the issue is if we change it to D, you'll see it still searches for all the S's, so on and so forth. So then the question is, how do we get our search value that we had before into our SQL? It's not like we can dump a variable in there because it will confuse the Python. So what we're going to do is take advantage of a Python technique called an F string. And I'll be honest, I've forgotten what the F stands for, but it's a super simple concept. We just put an F at the start of our string, so it's F string quite literally. And then what this allows us to do is to insert variables by putting a set of curly braces in our string. So again, if we want to access the data, we say self search text. So if that's an S, like it was before, it will search for all the S's with the wildcard, meaning that we don't care what's after it. Alright, so let's save that, kill the terminal, and retest. So if we search for all the customers that begin with S, you can now see we get those customers. If I change it, so all the customers beginning with the letter D, you'll now see a different series of outputs. Alright, so we've now successfully created an SQL statement which takes our input and returns the data that we want from the database. Alright, so it's that progression of, start with the big SQL statement and then gradually refine it until you get the exact data you want. Alright, and that works for, any sort of complex SQL statement that you're trying to write. Again, ideally you're doing this in the development phase. You shouldn't be doing it as you code. But as I said, it's something I haven't touched on with some students before, so just wanted to go through that process on the video so you could see it in action. But I am planning on doing another video explicitly discussing that decomposition process. Alright, I guess the thing you will notice though, if you have a look, is it's still very raw, the data that we're receiving. So you'll notice if you put your Python lens on, that the query returns a list. The square brackets denote a list, and each item in the list is a tuple. So a tuple has the round brackets. It's like a list that we can't mess around with as such. Alright, so what we want to do is we want to parse the actual data out of this list rather than having it just as a chunk there. We can't do much with this at the moment. So we're going to close the terminal, and what we're going to do is, instead of just printing the entire query, I'm going to comment that out now we've got things working, is we're going to take an iterative approach, and we're going to say for each result in our query, because remember our query returns a list, so we can iterate through the list. And rather than say return the whole query, what we're going to do is we're going to say from the result, so each particular element in the list, which in itself is a tuple, we want to access the first element, so element 0 in the tuple, which is just the name. Alright, so we've created an iterative loop which will basically suck the name data out and add it in its own label into our results. So if I save this and we run it again, so S, you'll now see we've got our 6 names listed vertically, and there's no brackets or parentheses or any sort of Python syntax surrounding it. Alright, so once we've got to this point, we know what customers we have. It's a case of, well, how do we access their individual data? And so this is going to be done through another query. And I guess similar to our setup here, we're going to have to include some sort of button to essentially action the SQL statement for the particular user. Alright, so again, because we don't know how many buttons we want to have or add, we're going to do this process dynamically. So it's all going to occur here in the Python file, not in the Kivy file. So rather than just return our result as a label, alright, we're going to return a label, but then also we're going to return a button. In order to make this a bit neater, I'm going to also set up for a result row a box layout. So again, we're going to use the box layout feature to organize our data. You'll see again, got the squiggly line, which means that it's probably something we need to import. So UIX box layout, and I'm sure you'll start to identify the pattern with these elements that we use in the Kv file. You know, they usually come from the UIX library, and then they have their own little sub library. We import the object with the capital letters. Alright, so we're going to have our results row. So rather than returning it straight into the results layout, we're going to take this result row object and we're going to add the label in there first. We're then going to create an order button. So I'm going to call it order btn for button, which is an instance of a button. And we need to add a text so we know what the button does. And I'll give it a size hint as well. Sorry, not colon, that's Kv talk equal to 0.2. So again, I need to import the button. So this might seem a little bit tedious, but the imports are always one time only. We know this, once we've got them, we can use them wherever we want. Button. So we've imported the button and set it up. Alright, so we can't just go in and add an on press element like what we've done previously. There is a bit of a different process for adding an action to the object. So what we do is we say order btn dot bind. So basically we're binding the attribute to it. So the attribute being on press equals, and then because we're going to have multiple of these order buttons on our screen and we want to be able to differentiate between each one, we need to include a method called partial, and then we can call our method. So I'm going to call it get orders, and we need to pass in the result 0. So basically we're going to run a method called get orders, but we also need to give them the name that we want to search for the orders for. So this partial, we need to import that, and this one's a bit trickier. It's harder to guess, but it's from an actual Python module or library called functools. It's used in multiple different aspects of Python, but obviously we're using it to bind an action to our Kivy button. Alright, so now we've set up our order button, we've attached the action that we want to occur. It's now just a case of result row dot add widget. So we're now going to add the order button onto our result row. And then same as what we did before, self.ids.results, add widget, and we're going to add this result row. So now instead of just adding the label, we're adding a box layout which contains within it the label and a button for us to then run our next SQL statement. So we save that, we give it a run to see how we've done. Alright, so we'll just keep going with S. Okay, so no attribute. Oh, okay, I know what I've done wrong. So I do need to go ahead and define get orders. And I guess I'll set it up now so it'll get confused otherwise. So self, so the name that we're searching, the customer name, and we'd also need to include this instance. So I'll come back to this in a minute. So I'm just going to put pass just so we can actually test that the button appears. I guess I could have just done that as well. That's the other option. But I'll leave it in there now that I've done it. So we say S. Alright, and so now you can see, oh, did I do size hint Y? I meant size hint X. Should be over here. But we've got buttons, so that's progress. I'm just going to change that to size hint X. That will make a lot more sense. S. There we go, that's more like it. Alright, so we'll now do the get orders. So as we said, we've got self, which is the same as what we do with any method within our screen object. Just means anything in this object is referred to by self. Get orders. So, oh, sorry, no, that's the function we're calling. So this name, so result 0, is going to be called name in this method. It doesn't have to be called result 0, because then it doesn't matter what this is. It's always going to be name in this method. And then the instance, basically this is what pairs with this partial to sort of say that, well, the get orders is only for this particular button. It's not for all of the buttons that have the same method attached to it. All right, so we won't actually use this instance in the function lines, but we do need to include it so Python knows that, oh, okay, it's only this one get orders, it's not all the other ones that haven't been pressed. Alright, so when we get the orders, the first thing we probably want to do is we want to clear the interface so that we can actually display some more information in there. You may have seen previously when I was testing multiple queries that they sort of just, the data stacked underneath each other. Alright, so what we can do if we want to clear that part of the screen, we can just say self.ids.results.clear widgets. And so basically this will just wipe the whole result box layout clean, so there'll be nothing in there to start with. Alright, but then after that the process is pretty much the same as what we did previously. We have to put in our SQL statement. And so we'll do it as an F string so that we can pass the name into it. So select all data from orders where the customer name is equal to, in curly brace we put name. You do have to put quotation marks around it too so that it runs the SQL statement with those quotation marks in there. If you leave them out, you'll find that it'll chop off the last name and then it will throw an error because of the space that isn't inside the quotation marks. Alright, so then the query line is exactly the same as what we did before. So query equals query app, I can't spell, query app dot read, data dot read data. There we go. Now we're on a flow. Query app dot connection. Run the SQL. And again, because we're going to have potentially multiple results, we're going to iterate. So for result in query self.ids.results add widgets, and we're going to add a label. So we've already imported it, so we don't need to do it again. Text equals string of the result. So we'll save that, rerun it to test our adjustments. So we've now got search for S, we still get our names, we still get our buttons, but now if we search in all orders, we now get all the orders for Sam Winchester. Alright, so we've now successfully found all the orders for the customer that we searched for. Okay, so finally one more query just to look at is, say we want to get the total of all of Sam's orders. Alright, that we could go through, we could parse through the data, rip out all the numbers, and obviously calculate it up. But we can also do that using SQL. So that will save us a lot of time. If that's literally all we want, is we want the total value of all the orders or all of Sam's orders, rather than having to write another whole thing to make that happen, we can get the database to do that for us. So similar to before, we're going to add on a bit more, but we'll do it after we get our results. So what we're going to do is we're going to add a new button called total button, and it's going to be an instance of a button with the text equal to calculate total of orders. So now we've set up the button, we need to bind an action to it. On press, I'm getting ahead of myself here. On press equals partial self dot calculate. Alright, and we will pass the name in as well, so we can define for this customer the total. We don't have to, sort of drag all this data across. We can just use what we've already got. And then because we've created the button, we do have to add it onto the page. So add widget, total, BTN. Alright, and just to make sure we don't have a meltdown like we did before. Well, actually, before I do this, I'll test it to show you that if you don't bind the action to it, it will still work. I say hoping that it does work. Alright, so if we search again for Sam Winchester, you'll now see we've got a button here for calculate total of orders. Doesn't currently do anything because the action isn't yet binded, it's commented out. Alright, so if you have that error, you can just comment out the binding and then you can write the method later. Alright, but we're about to do that, so I'll uncomment. Going to write the calculate method. So again, we have self, we're passing in name, and then we always add instance at the end to again attach it to that particular instance that we've created. And again, it's the same process, SQL equals fstring select. So this time we just want the total cost. So I'm going to use the sum function. So I want it to select the sum of all the order costs from orders where the customer name equals, in single quotes, we then do our curly brace and say name. No prizes for guessing what the next line is. Query equals query up. Again, because we're practicing, I'm trying to fight the temptation to copy and paste so that I'm spending more time interacting with it and it is sinking into my brain. So then, because this is only going to be one result, I am just going to add it underneath. And again, this is just a prototype, so you can play around with the formatting later. No, I want to add a label which has text equal to string of the query. So the query should only return a single result anyway, so we can do string query. We don't have to do 0 or anything because it's a sum. It's literally going to return a number. But obviously we can't print a number, so we've still got to stringify it. Alright, we save, we run. So S search, so we've got Sam Winchester, who's got 5 orders. So if we calculate the total, it gives us $626.66. I may have lied about the formatting of what query returns. All right, but I guess that's a good a run through of that process of doing queries, adding in features from our Python file, whether it is a variable we've saved or whether it's an input from the Kivy. All right, as well as that decomposition to get our more complex sort of SQL. And then just some opportunities to practice some different things like sums, obviously like as a keyword, that sort of thing. So you'll notice the extension challenges there. Talk about things like parsing through this data and formatting it. So you'd be like set up a output row with data 1, data 2, or data 0, data 1, data 2, etc. Obviously you could format this to have a $ and that sort of thing on there. Alright, but the skills have been taught in this activity. I guess also you can adjust the search, so if you want it to search for first and last names. And there's a couple of hints there around how to do that. The wildcards can go either side of the letter, and also you may want to use the capitalize method. So say for instance, I'll refresh. said I'll refresh. There we go. And we search for a lowercase s. Right, it is good enough to return the answers, but maybe in some cases it won't pick it up. I guess the other instance to consider is where there is no output. So if you've dug deep into the database, you'll see there's no customers that actually start with the letter W, which is unfortunate to all the Williams and Wendy's out there. But maybe having some sort of case for what happens when this happens. What do you output on the screen? And that can probably come from stuff we've done previously. So I'm going to let you have a think about that. But yeah, that's how we create a search bar and use SQL to not only search for data in our database, but also to help us interact with it throughout.